Welcome to lesson 4.6, Use Congruent Triangles. So now that we've looked at the different theorems and postulates for proving triangles congruent, now we're going to look at using those congruent triangles to prove the idea of corresponding parts being congruent. So in any congruent triangle, we know the corresponding parts are congruent to each other, so that's the main idea we'll be exploring in this lesson. So example 1 asks explain how you can use the given information to prove that these two triangles are congruent. So a bit of a refresher off of what we've already done, but it's asking how can we use this information to prove that the triangles are congruent, and then based on that, we're proving corresponding parts are congruent. So given, they told us angle 1 is congruent to angle 2. So I went in, green arc on angle 2 and angle 1, they're congruent. We also know AB is congruent to DE. So AB, one congruent hash mark, congruent to DE. So before I do anything else, I draw in what I know. Then I know that angle CED right here and angle ABC right here are congruent to each other because their exterior angles are congruent to each other, meaning that these are supplementary angles to each other, same with these two angles. And because these supplements, 1 and 2, are congruent, using the congruent supplement theorem, we know angle CED is congruent to ABC. So I drew that in. I also know angle ACB and DCE are congruent to each other right here in the middle because they are vertical angles. So based on knowing angle ABC congruent to CED, ACB congruent to DCE, and then side AB being congruent to side DE, using angle side, we know triangle ABC is congruent to triangle DEC. Then based on that information, because the two triangles are congruent, DC is congruent to AC due to corresponding parts of congruent triangles being congruent. So once we've established that the triangles are congruent, we know any of their corresponding parts are also congruent. So side DC here and side AC here. Example 2. Another scenario with a picture. Use the following method to find the distance between the two docked boats from point A to point B. So we're trying to figure out the distance from A to B between the two docked boats. So they gave us some info or steps to do. Place a marker D so that AB is perpendicular to BD. So D is down here, already drawn for us. Find C, the midpoint of BD. So C is right here, midpoint of segment BD. And then locate the point E, so E here, so that BD is perpendicular to DE and ACE are all on the same line or are collinear. So the drawing's done for us based on this plan. What they're asking us to do is explain how this plan allows us to find the distance between A and B. So first what we know, because AB is perpendicular to BD and BD is perpendicular to DE, I know angles B and angle D are congruent right angles. So B and D are both right angles, making them congruent. With C being the midpoint of BD, I know that the length of BC here is congruent to the length of CD here. We also know angle ACB and ECB are congruent to each other right here in the middle because they're vertical angles. So then we can use angle side angle to prove that triangle CBA is congruent to triangle CDE, which tells us the distance between A and B is equal or congruent to that distance between D and E. So what they could do, saying that D and E is on the land and A and B is in the water, the distance between the boats, they could then measure that distance on land from D to E, and that equals the distance between the boats, AB. Example 3. Explain how you can prove that segment PR is congruent to segment QS. And in the image, they gave us some info. We knew angle RPS here, hard to see, but that's congruent to SQR here. And then we know segment ST here is congruent to segment TR here. So we're going to use angle side to prove that PTS is congruent QTR. Well, we already have a side here, angle here. So what we're missing is angle PTS is congruent to angle QTR because they're vertical angles. So once we've used angle side to prove the two triangles are congruent, then we use corresponding parts to show that PT is congruent to QT, which also means PR is congruent to QS because ST is congruent to RT. So if we took away those parts that are equal, we'd be left with PR congruent to QS. Example 4. Use the given information to write a plan for the proof. So they don't want us to write out the whole official proof, just the plan. So I'm going to look at my given info and then just write out a general plan. So based on my given, they gave me two angles here, and I can see that looking at triangle ABD, this one here, and triangle ACD, this one here, I can see that they share at least one side. So I'm going to use angle side to prove that triangle, and we also can look at BED down here, CED, see that they also share a side. So I'm going to first prove that BED and CED are congruent triangles. Based on that info, then I'm going to state that BD is congruent to CD because they're corresponding parts, and then I'll use side angle side of the bigger ones to prove that ABD is congruent to ACD. So the plan of the proof is just kind of writing out these steps that you're going to go to get to your conclusion without writing out all the theorems and postulates. And then lastly, we're going to look at example 5 here. Example 5 is, again, another proof piece where they just want us to write out the plan. So the plan for 5, they gave us the following info. GH is congruent to KJ. So KJ here, GH here. FG on top, congruent to LK down here on the bottom. And FJG, the right angle here, congruent to LHK, the right angle here. We're proving triangle FJK congruent to triangle LHG. So LHG, the one over here on the right, FJK, the one over here on the left. So the plan is, because I'm dealing with right angles, I know that this FJK is a right angle, and I know this GHL is a right angle. So I'm also using that info to start with using hypotenuse leg to prove FJG up here and JHK down here are congruent because they have the hypotenuse on each, a right angle, and a leg. So those two are congruent, which tells me that FJ is congruent to HL. So FJ here congruent to HL here because they're corresponding parts. Then we can show that angle FJK is congruent to LHG. And then we'll use side angle side postulate to prove triangle FJK is congruent to LHG. So again, in examples 4 and 5, the idea of a plan to the proof is just to write out your plan with the general idea in order, step by step, that you're going to go to get to your final statement. You're just not doing the second column of your justifications of the conclusions. But the main idea for this whole lesson goes back to this first goal, is once we know triangles are congruent, we know their corresponding parts are also congruent. So you first establish the triangles being congruent, then you can look for corresponding congruent parts.